Hi again, it's Katie here with Big Sky Robotics. We just finished our first ever Robot in 3 Days build. Next to me here we have our 2023 charged up robot. These 3 days we have learned a lot. We've had some failures as well as some grand successes, and we're really excited to share it all with you guys.
Hello, my name's Ethan, and I'm a mechanical engineering student here at Montana State University. Currently in my junior year, and I'm really happy to be part of this team for his first year. So, right here is our arm concept. This is a virtual 4-bar, basically meaning that it's driven by a motor that moves the second arm in relation to the first. So because of the gear ratio we use in the pulley system, the arm will raise as it increases rather than staying parallel as a normal 4-bar would. So we learned a lot from this arm right here, including generally the method of power transfer causes a lot of issues, and we're not currently able to fix it because we don't have the correct equipment on hand to do so. So we used belts, which was what we had on hand, and it did not work because of the high torque required to increase to raise the arm. So, and not only that, the pulleys we used were 3D printed, meaning that they tended to bore out and strip along the hex shaft. And some of the pulleys were too small to bolt to anything. So that's something that can definitely be improved upon. One of our design concepts to change it is to use sprockets and chain instead. It will give us a better, basically, ability to transfer power up the arm. We did get it to move once, and it moved fairly well with the help of these air cylinders that act as kind of constant force devices to provide help to basically the weight of the claw at the end. So overall, generally, it seems that it could work, although there will need to be a few more tweaks to allow it to do so.
Hello, my name is Tyler. I'm a freshman here at MSU, and I helped build this grabbing mechanism to pick up cones and cubes. And the main part of this is it's able to self-right the cone when it picks it up. It has these 3D printed spinning compliant mechanism, and we are able to adjust the angle of the wheels when you pick up a cone, and because it spins, it will self-right itself depending on the angle, so the bottom will always face down, so you can easily place it on a pole. And another big mechanism that we have on here is the fact that we can change the size of the clamp. So in this case, you'll be able to clamp the blocks because it's larger and we don't want to pop them, and so they'll only go a certain distance and hopefully won't pop them. And then when you flip the other pneumatic down and go out, it brings it in closer, so you're able to get a better grip on the cone and really able to some cons that we had, some problems that we had with this mechanism is the 3D printed parts were very small and fragile, and so we broke a lot and had to replace them. The something good about this is the fact that it's able to self-right, which is a big thing that we've been noticing with the cones. It's hard to pick up a cone if it's on the ground, and so this will really allow teams to just kind of move the arm wherever and still have the bottom face down.
I'm Jonna with Big Sky Robotics, doing a final overview on our intake, one of the intake designs we've been working on. This intake, we're using primary compliant wheels to intake both the cones and the cubes. So far we found good success. We just got our cubes about half an hour ago, so we've started testing it with those and found we need to adjust dimensions, but with our other prototypes for the mock-ups of the cubes, we found a decent success. One of the things we learned was the angle of attack on the intake is pretty important. So we might end up recommending that teams have more of a fixed intake and transfer it through into the main body of the robot, just passing it straight back to the intake. Another thing we've noticed is the bottom of the cone and the face of the cube are much closer than the initial dimensions seen. So some type of compliant intake that can pass through cones in any orientation is very realistic. So you would have some pass-through mechanism and a grabber to then grab it inside a robot and move it on the end of the arm, leaving the intake mounted lower.
My name's Justin. This is the charged up game piece, kind of the teeter-totter for the game. One of the main difficulties with this game piece is the balance portion. With the size of the robot, getting exactly in the middle and balance is definitely going to take some time and is going to need some very small increments for movement. Building this, we just used some 3/4 inch plywood and some square brackets with metal underneath to give some good support. This is a very rough sketch version of the game piece. It's enough that it'll get the point across, but definitely not the level for the game. But yeah.